ready? Let me know.
Check, check, 1, 2.
Test.
Asking them to get in here now. Hi there. Whoa, wake up. Sorry. Okay, we're going to start in a couple of minutes, but we're going to start with a poll. So if everyone could start making their way in here, that would be great. The poll will be very quick, but it's also very important. So folks outside, start making your way in, please. What? Okay, good. But I need everybody to stay within a certain frame. Well, okay. What do you want me to do? Just stay where you're at. Okay, I won't move. Don't pace this. I will not move. Tempting, but I won't do it. Folks, if you can make your way in here, I see a lot of empty seats. Let's fill them up so we can get started.
Yes.
We have a question about the future of this conference, at least for next year, that we would like to get your input on. So come on in, please. Please come in. Please, please, please come in. I see people walking around. Come on in. Critical question coming up. Please come in now. Okay. I guess a lot of folks have gone bowling, but if you're out there and you're going to come in, now is the time to come into the room and have your hand counted. Okay, so the question, there's a question for next year. Right now, we have an active proposal from a group in Montreal, Canada. Nice city, but we realize that some people can't necessarily travel there. I can't imagine not wanting to travel there, but what I'd like to know is if we have, and this is informal, of course, if we have the conference in May, it would be in May, in Montreal, would you attend? Raise your hand. Okay. And how about if you would not attend? Raise your hand. Okay, well that looks pretty good actually. So I am going to hold you all to that, by the way. I forgot to say that. No, whatever, we'll find out.
Très
Thank
bien.
you.
Très bien. Hi. Hi, everyone. Let's see. I have to get to the announcements. Okay. No, there are no announcements. We can go straight to the talks. Now, so in this session, we start out with 2 talks that are on Zoom, and then we have 2 talks in person, and we have them all loaded up, so it'll go real fast, and we'll get to the end as quickly as possible, and we can all go and take a nap. But, all right, first, I am going to load up the Zoom. Where is this? This one. No, it's I forget. I thought I had this all set up. Right. And this one. All right. Okay, the first talk is protecting digital library resources through machine learning-based detection of automated access patterns. That's ML, not AI. And we are going to load up the Zoom, and Esme is going to do some magical things. And our audio is that? What? Oh, join with computer audio. Yeah, we should do that. What are AI scrapers? Oh dear. Good. So are we waiting for Nima? Nima Asadi?
Hello, I'm ready.
All right, we can hear you now.
Okay, great. I see it on this screen actually, but okay. Let me play this.
Okay, you can go ahead and start.
Okay, great.
What?
Well, hello everyone. Thank you very much for this opportunity. My name is Nima Asadi. I'm an application developer with the Consortium Library Application Support at the University of Maryland in College Park. And I'm going to present my talk titled Protecting Digital Library Resources through ML-based detection of automated access patterns, basically, which will talk about AI bots and how we can end their challenge and how one of the ways that I propose about how to deal with them. So before anything, we want to know what are basic AI scrapers. Automated agents like bots or scripts that crawl sites and to extract content at scale are basically everywhere nowadays, as opposed to, for instance, a few years ago where LLMs were not existent. And their behavior is changed, and they have been very dynamic. They have been a lot more basically problematic. These aren't casual scrapers. They systemically enumerate URLs and harvest entire sites sometimes. They are powered by vectorization, large language models, OCR, embeddings, and screenshot text, etc. Modern bots don't just read HTML anymore. They can process PDFs, images, screen views, etc. They are often used to populate AI models like RAG systems, retrieval augmented generated systems that are used by agents or people to harvest people's data and generate chatbots based on those. Basically, they feed private or specialized corpora of data into vector databases for downstream chatbot development, QA, or summarization, etc. They're faster and more stealthy than traditional bots and traditional SEO scrapers. They, instead of hammering 1,000 URLs per second, they mimic human pacing now. They can mimic human pacing. For instance, they can sleep between bursts of requests and etc. To blend in. So why are they exploding now? The generative models must be trained on data, and there's massive appetite for data. The better the model, the more diverse, wide, and freshly sourced the data must be, basically. And the cost of acquiring unique or uncommon data is now basically a competitive advantage. LLM companies need basically fresh recency, basically news, reviews, and other papers, scientific papers, publications, etc. Models without recency, model without the news, without the updates, are not as smart, and users expect up-to-date knowledge in answers. So basically, these companies are or agents are racing to continuously harvest content from websites. Also, search engines are shifting towards answer engines. So business model is basically migration from 10 blue links to the synthesized answer to generate direct answers for people, as opposed to just providing links. Therefore, the trends of web scraping has been exploding in the past few years, especially since these changes in the trends of the industry, and also the agents. What are, however, the impacts on web services? So traffic doesn't mean humans anymore. Server load is not tied to real users. So the infrastructure graphs look like growth, but may actually be robots farming the contents. So this can break basic capacity planning. Also, they do API bypassing. Scraping makes paid APIs less attractive for websites. In other words, if your data is available through a GUI, for instance, bots can reverse engineer it and bypass revenue streams. So this basically removes or worsens the economic incentives for building high quality APIs or good APIs. Also, license and copyright leakage. Open access page basically gets vacuumed because even attribution required limited license or fair use content gets taken wholesale, taken by these bots, basically, is harvested by these bots. So once they're scraped and embedded into LLM corpus, the original authorship, the actual authorship, the whole concept of authorship becomes extremely hard to enforce. Also, content value gets inverted, and basically rate limiting arm race will be an eventual conclusion of that. More filtering, more aggressive bots means more aggressive bots. Every new anti-bot defense basically triggers new evasion, more sophisticated ways of harvesting, crawling. So these are basically some of the main impacts on web services. And but how are they evolving? Another challenge is that LLM agents read robot.txt. Robot.txt are basically recommendations by websites to ask bots to not, for instance, to follow some rules. So they don't hammer the website. They don't basically put the websites or web apps or services into danger. So the bots can actually, the more sophisticated bots can actually parse its semantically. They can read it basically, but then choose optional or optimal violation strategy based on that. It used to be, robot.txt used to be basically sort of like a social contract. Now it's like just basically another file that these bots can exploit. They're also stealth, meaning that they do rotating IP pools to evade basically a lot of bot detection approaches. And they also extract DOM like HTML semantics and other basically elements. So modern scrapers don't just grab or harvest data or text. They interpret structure. They interpret the markup meaning, metadata, etc. And so these are some of the ways that they have been evolving that we have noticed, and they may become more and more challenging for us. What can we do? Some of the main approaches that have been done in the past and in recent years is one is, for instance, putting on them under paywalls, API keys, tokenized access, basically limit-free access, and basically gating high-value content behind authentication approaches. So harvesting becomes more expensive and basically technically harder. And also explicitly prohibiting LLM training, updating terms of service. It has been less basically effective, but that's one way that some places, some companies or owners try to somehow avoid the bots, or a combination of all these. And or official paid date feeds and making scraping basically less economic, offering clean, cheap, reliable feeds or APIs instead. So price and quality maybe can beat the cost of building scraping pipeline for some users, some people. And they're creating, and also another way is an approach that is the topic of this talk, and for the rest of this talk, is creating our own early machine learning-based bot detection. Basically, investing in models that can learn distinguish between normal user behavior versus bot user behavior. And so that's basically the topic of this talk, and I mean, for the rest of this talk. And so this graph is a very general, high-level depiction of the model. Basically, we take the access log of the web service, and then which has the information for each user, including their IPs, etc. And then it's processing. We process this log, this messy basically log, and it extract certain features that we are interested in. And I'll go over those features very quickly, and then feed that into a machine learning approach algorithm, basically dynamically and as in a streaming way online. And the machine learning algorithm basically detects each user, if each user is a bot or not a bot, based on their behavior. So for this implementation, so there are multiple ways to implement this using different machine models. The way I implemented this for our systems was using basic anomaly detection. Anomaly detection is a model in machine learning, type of model in machine learning that finds anomalies in the data as opposed to data that is more balanced. So, for instance, bots are usually an anomaly versus like non-bots. Otherwise, it would be really a huge problem. So they're unsupervised anomaly detection models that I use, including isolation forest and other IOF and COPOD, but I'm not going to explain those. They're a little bit beyond the scope of this talk. So what are some features that here in this slide I'm talking about? So one of them can be a request per minute. And so human behavior is different than bot behavior, but as regards to request per minute or request times, how many times they request content. So humans click something, page loads, we read the content, then maybe scroll, maybe get distracted, etc. So average is a few requests per minute usually, but bots usually can turn into loops and hit URLs like nonstop or as a batch schedule. They can generate hundreds to thousands of requests per minute easily, even sometimes millions. And because they don't need cognitive time, they can just run the machine speed. The machine can be run. And another for instance, other features are average time between requests. So humans, but humans usually time between requests or two actions governed by their attention so typically between 5 seconds to 60 seconds. Basically, or more, maybe, or sometimes people are rushing, but they don't click every like 0.2 seconds, for instance. And bots have a completely different way of looking at these usually. However, some more sophisticated bots, as I mentioned earlier, try to mimic humans. And then unique paths requested, what does that mean? Is that, for instance, humans, that's the picture on the right side, humans care only about specific pages usually. User session usually is a home page, 3 to 10 item pages, maybe search or filter something, etc. But bots, scrapers want usually everything. They crawl the entire domain. They fetch many different unique URLs, etc. And so bots are usually like hungry, and they work very quickly and fast. And another one is meta distribution. So metas are usually, by meta I mean gets, posts, etc. for people who are more into how web and APIs work. Humans usually get for pages and post when submitting form, obviously, login, search, when you're commenting on something, etc. But bots usually, the way they work is, and scrapers, is 99% get. Basically, they mostly just use get approach a lot more than humans. So this, so there's an example output of the model, basically. Here is an output image of the model for the owners of the web service, where all the users within a certain period of time are ranked based on how likely they are going to be a bot based on their behaviors. You can see each column is a feature, and on the left side we can see the IPs, and on the right side there's a ranking of basically how many, what the models think is a bot or not. So I used three different models to increase the reliability of the tool, and then at the end the models do a voting system, basically average voting, to see if a person is a bot or not. And then in this, and as another example, basically we see the model score for the top bot suspect, and basically the three models, you can see how they voted based on that, and the average is the ensemble vote. And then on the right side, we can see the radar graph that shows how that one specific user or bot behaved in that specific period of time, based on with regards to those features that I mentioned earlier. So I use, as you can see in this slide, over 7 or 8 features that I thought would be more useful for this, and actually based on results and empirically I generated them. And these features are basically based on some research papers that I was looking at to understand how bots usually behave versus human, based on empirical research papers, including some papers, I think, from Code4Lib. Future goals for this approach is basically we want to understand, and the challenges, we want to understand when bots mimic human pattern and mimic browsing pattern. We need more research for them to understand them. The bots are, as I mentioned, evolving, and it's challenging to find out how they basically work. Also, a more smart approach where the model changes based on the bot's behavior would be very useful. And in other words, adaptive detection of the bots, and also basically in this approach, we have bots that are in this model and in this tool. Basically, I'm taking the log every once in a while, for instance, every 30 minutes, every 10 minutes, every 5 minutes, and then analyzing all the users' behavior in those within those time. And then models decide based on those data on how many users are bots or not. However, we can make it event-driven. In other words, once the model finds a bot, it emails the user, as opposed to just giving a summary every once in a while. And that's another future work for this approach. So that's basically all my. I see my screen here, but I don't see my
Thank you very much.
Okay, thank you very much.
Yeah.
Thank you very much. I appreciate it, and I'm happy to answer any questions if there are any.
You can't hear the audience, but there's good applause, and that's probably because this is a pain point for a lot of us. All right, I have to close the Zoom and bring on the next talk. right. To go to here. And so the next talk is, did it launch? No, here I have to do that. So the next talk is from Seth Erickson, offering on-demand virtual machines to library users. Am I supposed to reclaim host? Yes? All right, let's just stay. What? So I will. Good? All right, Seth, welcome. You can start.
Okay, hi. Thanks, everyone. My name is Seth Erickson. I'm a data services librarian at UCSB. I know some of my colleagues were able to make it out in person, but I'm grateful to have the remote option. I work in a department called the Dream Lab, and a big part of the Dream Lab's work is providing resources, especially data analysis tools and training to our community. So we're the home of the Carpentries community, if you know Carpentries workshops. And so for a bit of context, there are several research computing groups on campus. However, to use a lot of those resources, especially the HPC resources, students generally need some kind of approval. So there's some gatekeeping. There will be a faculty member or a PI, or they need to be enrolled in a specific course. So we recognized an opportunity to provide on-demand resources, on-demand computing environments with minimal gatekeeping and some commonly used data science tools. We launched this service about a year ago. It's a pilot. It's fair to call it a pilot. And in this talk, I'm going to give an overview of the service, discuss how it's being used and managed, and some future directions. Just 1 second, sorry. So this is called the Coder Workspace service. This is our, and we are offering on-demand virtual machines with commonly used data science tools, so RStudio, Jupyter, VS Code, and the like. So anyone with a UCSB account, a UCSB NetID, can create one of these workspace virtual machines, and they can use that for a quarter. And at the end of the quarter, so we're on a quarter system, and at the end of the quarter, those workspaces are deleted, and that's an important feature of this because it helps maintain, it helps us kind of clean up resources, and it kind of makes the service overall more manageable. Users can access these virtual machines through a web browser, and the virtual machines themselves run on an on-prem Kubernetes cluster using the Harvester framework. So it's virtual machines running inside Kubernetes, and importantly, that cluster is managed by another research IT group on campus who we're really grateful to have their partnership on this project. So these virtual machines are not HPC resources. They're very modestly resourced. They have 4 cores, 16 gigabytes of RAM, and 64 gigabytes of disk, and then you get them for the quarter. And as the name suggests, we're using this product called Coder. Coder is an open source, self-hosted service for providing cloud-based development environments. It's really targeted towards software development companies. But it is open source. It has an AGPL license. It is a commercial open core product. So, and we are using only those features, those functionalities that do not require an enterprise license. So I'm going to quickly step through some of the screenshots, some screenshots of the user interface, just to give you a sense of how workspaces are created. And so users would start by going to a portal for the service. There's no point for me linking to it because you need a UCSB NetID, of course. After you log in, there's a big button to create a new workspace. And then there's this form, what we're looking at here, that's filled out to create the workspace. The only required field here is the name and a checkbox that you've read the usage policies. There are a few optional fields like include RStudio, and there's some other ones that are cut off at the bottom to install other optional software. You'll also notice at the top that the workspace is called, it says Coder Workspace Winter 2026. So this is the name of the template that I'm using to create this workspace. There's only one template at a time, and this naming convention helps me track, basically track VMs. It helps me enforce this policy of deleting VMs at the end of each quarter. So I have a new template that I create on a quarterly basis. When you are creating the workspace, it takes a minute or two to come up, depending on the software that you've installed. If you're familiar with Terraform, you might recognize this log output. The Coder service actually uses Terraform as an internal library to manage the workspace lifecycle. And in fact, workspace templates are defined using the Terraform configuration language. I'll come back to that. But at the bottom, you can see it says creating Harvester virtual machine resource. That is the Terraform resource, creating that virtual machine in the Harvester environment. Once the workspace is created, users are directed to this workspace dashboard, which is what we're looking at here. There are a couple of buttons. There's a button to start VS Code, so that would bring up VS Code on your desktop computer, and it would install a plugin to connect to the workspace. I configured this workspace to have RStudio server installed, so I have the web browser interface into the RStudio environment. There is a file manager that you can use to upload and download files from the workspace file system. There is a help button that links to this documentation page, which goes over kind of the resources and the software that's installed and the policies themselves. And there are a couple of guides on things like connecting to Google Drive and using RStudio and Marimo notebooks and things like that. We're constantly adding to these guides recently. You can also see the workspace, the resources for the virtual machine. Again, these are modestly resourced machines. Sorry, I need to go back to the slides. I also want to mention that users have root access on these computers, on these virtual machines. So they can install whatever they want and they can run servers. And you see there is a little ports drop-down menu in the top right corner there. They can using that, they can connect to TLS terminated endpoints for a secure, like if you're running a web server on port 8080, you can connect over TLS to that port using this, this termination right here. Second. And this is all just how Coder works. Going into a little bit more technical detail. So this is the, talking about so how the various components are related. Users interact with the service through their web browser or through VS Code. There's also a Coder CLI. The Coder server itself is running in an AWS VPC. It's just a single EC2 instance running a few containers, the Coder server and a Postgres database. I'm not aiming for high availability just yet. The Coder server runs with credentials that allow it to create and manage virtual machines in the Harvester cluster on-prem. And when a workspace is created, that virtual machine will include a client that connects back to the Coder server and establishes a WireGuard connection. And so all the communication between the user and the workspace goes through the Coder service this way. Okay. So I'm going to quickly skip ahead a little bit since I only have 2 minutes remaining. So I do want to emphasize that it's really important for the sort of financial viability of this or sustainability that we're using on-prem resources. As I already kind of mentioned, the Coder workspace templates are defined using Terraform. This is a screenshot of of Coder's built-in template editor, and so we're seeing some of the Terraform configuration here. I find this to be very flexible because it means that you can connect Coder to other kinds of services. I've connected it to Jetstream 2, which is an NSF research computing cloud that uses OpenStack. You can connect it to all kinds of clouds. It's a very nice way to configure this system. And the form through which you create these new workspaces is also, all of those input fields are defined, in fact, using this Terraform template. So how has this been used? It's been used very lightly, mostly because I need to do more outreach around it. In fact, a lot of our usage is in the library itself. We use these workspaces for consultations, for quick one-off tasks. There's a small group of graduate students who have been using them. Anecdotally, it seems like they're using them for data harvesting tasks. But increasingly, we're seeing that there is a use case around coding agents, which I'll talk to about a little bit more. How this is being managed, it's just me, but it's not so bad. I'm using a lot of infrastructure as code tools, which has helped me kind of keep track of things that I need to manage, every now and again. The Coder service is very lightweight. It's a containerized application, and there's very minimal persistent state, which means I can kind of, between quarters, basically wipe things out and rebuild them as I need to. There's a little bit of care and feeding in the sense of keeping track of these template images. So every quarter I need to update the template, test it, and then communicate with users about the life cycle of those workspaces. But for the most part, I focus on outreach, and in fact, as this suggests, I need to focus more on outreach. And I want to end with how this is evolving. So we're using this, or thinking about using this as a data access mechanism and for AI. That's probably good enough. Thanks.
All right, thank you very much. All right, now we come back. If you have questions, do it in the Slack. Now we have a in-person presentation. I have to end this meeting. Right, and then yours should be.
I can do it.
You can do it?
Yeah.
So PowerPoint, yeah, modularity. All right, the title is Modularity, Why Doing It All Isn't a Good Thing. And our speaker is Kyle Riley.
Does this one work?
All right. No,
Okay.
use that one. Use that one.
Okay. Hi, everyone. This is Modularity, Doing It All Isn't a Good Thing. In repository development, we often find an open source product that tries to do everything, or we try to build our own. We try to have a media viewer, publishing, search, ingest, all in one package. And while that software works at launch, over time, systems that try to do everything become a nightmare when you try to upgrade them or try to improve them, which is something you only discover years later. My name is Kyle Riley. I'm a lead software developer at the University of Texas at Austin Libraries. And today I'm going to walk through the architectural patterns that we went through, where we are now, and how we ended up building shared infrastructure instead of individual sites. This is how we got to Portal. The problem we kept repeating. For years, our pattern looked like this. A librarian would come to us and they would have content that they wanted to put online. We built a repository, we launched it, and then we moved on. The software wasn't bad, the problem was that we moved on. Software ages fast. We're a team of 10 developers managing roughly 14 different sites, and many of them have started expiring all at the same time. So now we have to do all these major upgrades all at the same time. So this is our journey to fix that. So pattern one, the platform. This is where we started, and this is where I'm sure most of you start. You find an open source software that does like 90% of what you need it to do. It feels amazing at first. You're like, whoa, I'm almost done. All I have to do is just deploy this software. But that last little 10% of customization slowly turns into 20%, then 30%. Before you know it, you weren't really maintaining, or you're not really using the platform anymore. You're maintaining a custom monster within it. So, and upgrading that Frankenstein becomes full-blown projects requiring, which required, and those security updates felt like we were building the system from scratch every time. And we're also at the behest of their own upgrade schedule, not our own, so we can't upgrade when we want to. We have to upgrade when they want to. So we said, fine, we'll do it ourselves. So architecture pattern 2, the fully custom project stack. We went fully custom. We built Isla as a fully custom system, Django backend, Next.js frontend, custom Solar integration. It worked beautifully, total control, no upgrade anxiety, no longer on someone else's schedule. And then we built AHPM the same way. We copied and pasted our custom code into a new repo, made a few adjustments, and stood up another site. Bam, done 2 sites up. It felt efficient, it felt empowering, but each site had its own backend, its own front end, its own code base. We solved the platform problem, but created a new one. We were duplicating ourselves, and the problem with that is that the newest site, HPN, got improvements, a new search, better browsing, a faster media viewer. The older site, Isla, didn't. It was left in the dark, cold, alone, waiting for attention, waiting for an upgrade. And then when we finished AHPN, we moved on again, and suddenly AHPN was in the cold, dark, waiting for an upgrade. So each new project improved on the last, but the old sites didn't receive those improvements. Over time, the code bases drifted so far apart that upgrades became another nightmare. So the upgrade nightmare would never end. So that brings us to shared infrastructure. So obviously this wasn't sustainable. We needed something different. We stepped back and asked ourselves, if every repository is basically doing the same thing, we store assets, we let people search them, we let people view them, why are we rebuilding it from scratch every time? So instead of designing a new backend and a new front end per project, we decided to design infrastructure that can be shared. This is architecture. Also, rather than designing software for one repository, we decided to design for all of the repositories all at once. So we decided to design infrastructure that could manage all of the repositories at once. On the back end, we consolidated everything into a single DAMS application. Instead of a new backend per project, we now have one source for all of our repos. We moved our content and media into Fedora 6 using the OCFL standard for long-term preservation. And we managed all that with a single Django app and one database. The architecture allows us to publish assets to anywhere, to Solar, to Elasticsearch, or whatever other search engine or index comes next without rebuilding our backend. We went from managing 14 separate decaying databases to one singular sustainable infrastructure. DAMS consolidates our backend, but our front end is still a mess of different code bases. So that is where Portal comes in. So our new shared front end Portal. So how does Portal work? Actually, Portal has 2 major components, a Next.js front end and a decoupled content management system, otherwise known as a headless CMS. In our case, we use an open source software called Strapi, but there are many, many other headless CMSs out there. Strapi lets us store and manage content, theming, and settings separate from our code. Each deployment of our Next.js will connect to a different Strapi database, allowing us to deploy the same code multiple times, but have completely different sites for each deployment. So what does this mean for y'all? For our librarians, we're essentially giving them Squarespace for repositories. If they want to change a search facet, update a translation, or reorder components on a page, they just log into Strapi and do it. No code, no deployment, and crucially, no need for a dev ticket. Our librarians have total control over their own content and their own sites. For our developers, this is about sustainability. Because Strapi is headless, the content is just data served via an API. We aren't married to any specific technology. If we want to swap the front end in 3 years with something new, say the Next.js, we can do that. Same thing with the Strapi if we want to switch that later. The content stays exactly where it is in Strapi. On the Next.js side, we've stopped building individual tailored sites and started building a library of reusable repository building blocks. So that's like IIIF viewers and metadata renderers and other things that you could use to populate a page. And we only have to write those once. Then we make an API call to Strapi, and it tells us how to render those blocks onto the site. By separating the content from the code, we've reclaimed hundreds of engineering hours while giving our librarians autonomy over their own sites. So, slowing down to speed up. Because building reusable components like this that work across multiple repositories certainly takes longer than just hard coding it. It takes longer than copying and pasting code for sure, but it also allows us to do something that we've never been able to do before, which is we never stop improving the code base. A new project doesn't force us to abandon the old one. When we improve search, every site improves. When we improve accessibility, every site improves. When there's a major upgrade that comes out, we upgrade it once, not 14 different times. We just upgrade it once, and it's upgraded everywhere. We're only managing one code base, one system, and then that changes everything. Okay, so the next slide is a video, and it has audio, and it comes on very strong, so I'm sorry. Okay, play. This is Lottie. It's built using our Portal code base. It has your basic things that you would expect from a repository: search, navigation, branding, but Lottie is built with a shared system underneath. This collection page isn't hard-coded. It's built from reusable configurable blocks that define how each collection is displayed. We define those blocks using Strappy, our headless CMS. Strappy comes with a content manager, a media library, a content type builder, a marketplace, and some settings. In Strappy, we've defined a custom content type called a page. A page comes with a title, a slug, a body, and then at the bottom, you can customize or add any blocks that you would like to the page. Let's add an info card block to define a collection to our collections page. Each of the fields that you see on your screen were created using the content type builder within Strappy. They were all defined and created by us for our portal site. The fields define not just what content exists, but also how the content is displayed on the page. Before publishing, we can preview the changes. And once ready, we can hit publish, and our collection will appear on the site. Lottie is a multilingual site. It comes with English, Spanish, and Portuguese, but you'll notice the collection block doesn't yet exist in Spanish, so let's add it. Strappy comes with built-in language support. Here we go to the Spanish page, and we add a new Spanish collection. We hit publish, and there it is. Let's see how search works now. Search is built into the infrastructure of Portal. Every site will come with search. You'll be able to display results and see facets. Everything you currently see on the page is customizable. The cards, the facets, the filters, all can be defined within our headless CMS. Facets, filters, sort behavior, display settings, none of this is hard-coded. If we would like to define a new facet, all we need to do is add an entry and define the key fields from our Elasticsearch. We don't redeploy, we just update the settings within Strappy, hit save, and publish. After publishing, genre now appears as a facet. If we hit the drop down, we can see a list of facets, and then we can filter by photographs. This gives our users complete control over how collections are explored via search on their individual sites. Now let's look at another Portal website. I created this one for Code4Lib 2026. You'll notice it has different branding, different content, a different theme, but it's deployed from the exact same code base as Lottie. That means when we improve Lottie, whether it's search, accessibility, or performance, this site will also improve automatically. We update the system once, we update the code base once, and every repository benefits. Okay, so why this matters. I'll end with something a little more personal. One of the hardest parts of our old approach wasn't the upgrades, it wasn't even the technical debt, it was watching projects decay. Spending a year of your life building a repository, thinking about search, metadata, display, getting the site just right, and then just moving on. And every time you open it a year later, you see something that's slightly off, a search behavior that could be better, a metadata display that could be cleaner, an accessibility issue you could fix in 5 minutes if it were today's project, but it's not today's project. Priorities shift, times runs out, and you have to just leave it. That was frustrating. Portal for me wasn't about designing a new stack, it was about fixing that. It was about building infrastructure that lets us go back. Now when I see something that could be better, I can actually go make it better. I fix the component and every site improves, and that changes how we build software. We're no longer leaving repositories that age and become outdated. We're building systems that continue to evolve with time. And for an institution whose job is preservation, that feels like we're moving in the right direction. This is my contact information. Thank you very much. Also, sorry, and this is my team. And that's my team. Thank you.
And exactly on time. All right, next. And our last talk for the day is Spreadsheet to Service, Building a Zero-Cost Search Interface, The Lackley Story by Eric Silberberg. And I should note that Code4Lib has reached peak Eric. If your name is Eric, please stand up. Yes, we have 1, 2, 3, 4, 5, 6. Yes, we'll get a picture later. We'll get a little picture. Okay, we also have to thank Esme, who's been doing lots of stuff for us. If your name is Esme, please stand up. Find it? Just put that way. It should be. Yeah, one of those. There we go. Excellent. Thank you.
Good afternoon, everyone. So my name is Eric Silberberg, one of the critical mass of Erics, as Eric just pointed out, from City University of New York, Queens College. And I'm actually going to be talking about a project, a research project outside of my work at the library there, though it is related. So mainly today I wanted to talk about the Lackley story and how this project has been developing since end of 2020, 2021. So this is my first Code4Lib, and I really enjoyed my experience. Learned a lot, and so thank you guys very much. I'm very proud to talk about this project today, Lackley. And so Lackley is a free online index of free online resources relating to Latin America, the Caribbean, Latinx, and Iberian studies. And so online there's a whole host of digital collections, many of which are maintained by you. One of the collections that the last presenter just shared is indexed on there. And so these are digital collections of books, photos, videos, research data about the region. And Lackley seeks to improve the visibility of these collections by identifying them, by cataloging them, so to speak, and serving links to them to students and teachers via a simple interface. So we've had access from over 100 countries, and we currently have 50 volunteers working on this project. Many of them are probably colleagues of yours, the librarians at your institutions. Your Latin American Studies librarian is probably already involved in this project. And they use this in library consultations, providing materials to classes, and sharing them at research consultations. So a little bit about the history of the project. When schools went remote during COVID, students and teachers scrambled to find available online resources. And so Lackley began as a spreadsheet and crowdsource resources among especially Latin American studies librarians to find these sort of collections that instructors could use as they pivoted to online. Next, it started to like snowball from there, and our colleagues developed, they applied a description standard to sort of describe what resources are there to facilitate the discovery. And so they used the HAPI controlled vocabulary. For those unfamiliar, that's the Hispanic American Periodicals Index. That's a wonderful service provided at UCLA. Itself an index of journals and other scholarly materials about Latin America and from Latin America. Then it was joined by Colegio Mexico, a major research university in Mexico City, and Fundación Getulio Vargas in Sao Paulo. And that's now why the project is operating in 3 languages, in English, Spanish, and Portuguese. I joined to create a better interface instead of working off of a spreadsheet like this, and out of my own background doing research on Mexican education system, and my work at Queens College with our bilingual education and Spanish education programs in our teacher training programs. So our mission is to provide free access to LACLI and encourage participation, adding and describing resources that we index from students and librarians across the Americas. And so you have, there's on the screen here, examples of our editathons from the University of Salamanca in Spain and Flasco Andes in Ecuador. We've also had similar outreach and programs in Peru and at teacher training colleges in Mexico. So we had some needs for the project, and that was to have an easy or an intuitive ability to edit the data, because we had lots of volunteers coming in and out of the projects from multiple different countries collaborating on this. And we also wanted to have a simple site to maintain this with translation possible among the 3 languages. So for this, everything had already been working on Google Sheets, so we kind of kept that as a place where our volunteers, students, instructors, and librarians came in to describe resources, put resources into the system. We then could use, we're done using Google Apps Script to turn that spreadsheet into an API, and then simple static websites using JavaScript to call that API and bringing that all the data from our Google Sheet into the browser as JSON, and then filtering keyword, facet constructions all done on the client side. So a little bit about where we are right now with the project is translation is done with a simple language dictionary using a 2-letter language cookie that's dropped for the user's preference. So when they return, it knows that they prefer, to read in Portuguese. Keywords are handled, interesting to handle diacritics, and even Spanish speakers will misspell with accents, not including accents, so on and so forth. So we handle diacritics and just use the filter method in JavaScript to handle keywords. And then the facets are created based on the current user's search results. That was something that we recently were able to add to the project. So some help, and thank you to the breakout session before, got some leads on how to continue to develop this project. But one is any recommendation on how we can have a 3-language form that all spills into the same spreadsheet. Why is that? Because we're getting recommendations of resources, and these are coming from the national libraries, from universities in the region, and so they're making recommendations right now through 3 different forms. It's a bit of a pain, and so we would like to streamline that for our volunteers that are editing our data so everything's coming into the same place. The other area, if anyone has any suggestions and to find me afterwards, would be to speed up our call time from the sheet to the page. And so there's a bit of a delay once on the page load and it pulls the JSON from our from Google Apps script, it makes that request. It does take a moment or two for the full data to load. So any recommendations to speed up that process would be greatly appreciated. So thank you for your help on any one of these two items. So thank you very much. I left some bookmarks at the registration desk. I have some on me if you would like some as well. And feel free to explore the project, get in touch with us, or talk to your colleague, your Latin American Studies librarian, if they are working on this project, about the project. And thank you all very much for your time.
All right, thank you very much. He finished a little bit early. Anyone have some questions for Eric? Okay, well, we'll just go on then. And that was the last talk, but don't go anywhere yet. Because I have announcements. Okay, where are we? No? Let's see, it's this one. Yes. No? Maybe it's this one. Oh, there it is. Okay. So first, has anyone lost some or misplaced some earbuds? They're in a blue case. Anyone? Well, if anyone hears of some earbuds, I have them. Okay? Question. Have you enjoyed your conference experience? Yes, you have. Okay. So let's make sure it happens again in future years. We're looking for a host for 2027. That is next year. And for folks that are interested in hosting or helping to plan beyond next year, or if you're curious about hosting and would like information about this amazing opportunity, be sure to join us in the what? The what does it take to host a Code4Lib breakout tomorrow? Can't make this conversation or what happened? Oh no. I don't know what to do. I'm going to have to read it from my iPhone. Okay. Hopefully it's not messed up there. All right. Yes. Okay. Okay, announcements for the podium. Number 2. I'm sorry. I don't know what happened. I'm just trying to read the announcements for the end of the show today. All right. Yeah, what does it take to, there's a breakout tomorrow on what does it take to host a Code4Lib. A group of past LPCs have been working on documentation for each aspect of the proposal and hosting process and are happy to share that with any interested individuals or organizations. And of course, as soon as I read it on my iPhone, it appears on the laptop. Anyway, I'm going to stick to the iPhone right now. So shout out to our AV crew, Josh and Bronco. Hey. All right, thanks to Code4Libers Carrie Gordon and Esme Cowles for help with streaming. We're so grateful for all their work, and they keep on doing things, and we hope they keep on keeping on. If you are presenting, including lightning talks tomorrow morning, please visit the podium between 8 and 8:45 a.m. to load your presentation onto the computer. Please don't forget your badge and lanyard tomorrow morning. Put it somewhere handy, like your backpack tonight, so you don't forget to grab it on your way out the door in the morning. Good point. And speaking of tomorrow morning, if you are checking out of your hotel, please check your bags there and refrain from bringing suitcases into the meeting space. As you know, there isn't a lot of extra space in the room, and we do not have a secure place to store them. The hotel and most others will be able to take your bag and secure it for you near the front desk, where you can claim it on the way out. Now comes the good part. Reception logistics. Tonight, from 6 to 8 p.m. at Buffalo Billiards. It's just about 0.2 of a mile from here, about a 5-minute walk. And there will be a VIP room, that's very interesting person room, reserved for us downstairs. 2 shuffleboards, 1 pool table, all food and drink. Find a friend who wants to buy you a drink or food. There is a limited menu that doesn't look to be too restriction friendly, so plan accordingly. Happy hour drink specials until 8 p.m. See the website for the information. Also, tonight, game night. When? Tonight, 7 p.m. at the game night, well, in the lobby of this hotel. Join fellow Code4Libbers at the game night, hotel bar, and food service is available. And finally, tomorrow morning at 7 a.m., Jog for a Lib. We will meet in the lobby at 7 a.m., and I have planned out a 3.4-mile run down to the river and around and back. So you are welcome, whether you're fast and I won't see you very much, or whether you're medium slow like me and we can have a nice conversation, or maybe you just want to walk with some other people. I know there are people interested in doing a walk down to the river and back. So that should be fun. And that's all I have. Go to the reception. Come back tomorrow. Be happy.